Welcome back to another Algebra 2 video. I'm Mr. Hibble. Today we're looking at solving polynomials still, but now we're looking at the grouping method. Okay, this is factoring by grouping and using that to solve a polynomial. First thing we're going to do is just look at the factoring process. Okay, factoring by grouping, one thing you always want to do is check for a GCF first. How you can do that is just utilizing Desmos. Desmos has a GCF feature where you can type in each of the numbers and find the biggest number that multiplies into each of them. Always check to see if the four values have a GCF larger than 1. In this case, they don't. So we start by going into our grouping process. Grouping means you put parentheses around the first two terms and the second two terms. You make two separate groups. Once you have your two separate groups, what we're doing is finding the GCF of both. So I need the GCF of the first two and the GCF of the second two. Once you know the GCF of both of those, you divide that value out. So divide the first two by 2, divide the second two by 3. But we also need to check our variables. You have x cubed, that's 3 different x's. You have x squared, that's 2 different x's. So I want to factor out however many x's go into both of those. I know that I could take 2 x's out of both the first two terms. So I'm also going to divide it by x squared. I look at the second two terms. I have x, that's a singular x, and I don't have any x's in the second one. So I can't take an x out of 0, so I'm only dividing by the value. I'm not dividing any x's in the second set of parentheses. Well, when you factor by GCF, what you do is you divide it out, and that term goes all the way to the front. So I divide 2x squared out, it moves in front of this new group. We just need to figure out what's left on the inside. Well, 4 divided by 2 is 2. X cubed divided by x squared. You're dividing variables. When you divide variables, you subtract your exponents. So 3 minus 2 gives us that 1. Realize you don't necessarily need the 1. 14 over 2 is 7. X squared over x squared cancels. Second set, same idea. Move the 3 in front of your parentheses. See what's left over. 6 over 3 is 2. The x should still be there as well. And 21 over 3 is 7. Notice your parentheses in this case are the exact same. That is what is supposed to happen when you are factoring by grouping, if it is factorable. In this case, it is factorable because they're the same. Well, what that tells me is 2x minus 7 can be factored out even more. 2x plus 7. And how you factor it out is just like we did before. You move it to the front, and whatever it is multiplying with is the second set. Notice there's nothing between the parentheses. That shows the multiplication. 2x plus 7 was multiplying with 2x squared. It was also multiplying with 3. So I show it multiplying with both of those by putting both terms in the parentheses next to it. Now I have factored that problem. Same idea for this next one. You check for a GCF. There is no GCF in all 4 of the terms, so we make our groups. Realize, though, we always want a plus sign in the middle to begin with. So since the 18 was negative, I'm going to make sure the negative stays with the 18, and I'm going to have a plus in the middle here, and I can go through my same process. Find the GCF of your values, use Desmos for that. Check your variables. How many variables can you take out? I believe x squared again. Whatever you divide by goes in front of your parentheses, and see what you're left with. 30 over 5, subtract your exponents. 5 over 5, subtract your exponents. The x squareds cancel. Find the GCF of the second one. Desmos will tell you 3. You can move that out front and see what's left. But what happens in this one is when I divide by 3, I get negative 6x plus 1. And notice my parentheses do not match. Well, I need them to match. That's the only way this process works. So if I need them to match, I just need to change the signs. And how that can be done is dividing with a negative. Since the 18 was negative, the first number in the parentheses was negative. That means the value I take out, the GCF, when it's taken out, should also be negative. That will fix any sign errors you're having. Since your parentheses are the same, move it to the front. Whatever was multiplying with those terms is now in the second set. There is a process of if we have a minus involved. Let's look at this next one. Again, the first thing you should always do is check for a GCF first. So that's what we're going to do here. We have GCF of 63, 27, 147. You can include the negative if you want, and the 63. And Desmos tells us the GCF is 3. So let's divide the GCF out. Always check for a GCF first. Divide it out if there is one. So that means I'm changing each of these numbers because I'm dividing them by 3. So the 63 is now 21. The 27 is now 9. The 147 is now going to give us a value of 49. And the 63 also gives us 21. So check for a GCF. We divide that value of 3 out. Now I'm just going to kind of ignore that 3. I'm going to go to the inside, make my groups like we would before. Again, make sure there's a plus in the middle. If you need to move the negative to the inside, do that if it's there. Find the GCF of your terms. I believe it's 3x squared for the first set. Divide it out to the front of your parentheses, see what's left over, and you'd get this. We do the same process for the second set. Divide it by your GCF. That's a value of 3. The 49, the first number there is negative though, so I'm dividing with the negative. If you do your division correctly, it would give us 7x plus 3, which is exactly what we wanted. Our parentheses match. Now you can factor out the 7x plus 3 one more time to where it is now multiplying with the 3x squared minus 7, the two things that were in front. This is our factored form, but we're just missing one thing. We divided a 3 out originally. That 3 still needs to be shown. Now we have our answer for factoring that one. When we have 4 terms, we always use factoring by grouping. If you only have 3 terms, though, you can still use factoring by grouping. In fact, it's what you should do when you have 3 terms with an A value. Notice our A value is 2, our B value is 1, and our C value is negative 6. Well, whenever we had these trinomials, we were factoring them by finding 2 things that multiplied to A and C and added to our B value. And before, we only looked at when A was equal to 1. Our A value is now a value of 2, so this process changes slightly. Before we took a shortcut, now we do the full process because there is an A value. So, okay, A times C, 2 times negative 6 is negative 12. Our B value is 1. We need to find what multiplies to 12 and adds to 1. Find your factors of 12 if you need. 1 and 12, 2 and 6, 3 and 4. They multiply to a negative, so the signs must be different. They add to a positive, so the bigger numbers must be positive. Negative 1 and 12 would not work. Negative 2 and 6 would not work. The 2 values we find that works is negative 3 and 4. Well, whenever you have an A value for these 3-term quadratics, right? It's a quadratic trinomial. What we do is we do what's called splitting the middle. So you take the middle term, the 1x, and we split it. We split it to now be the 2 values we found on the right. Negative 3 and 4. But you can't just change things in math. It has to be equivalent. So we said that negative 3 and 4 add to 1, but we had 1x in this term. That means both of these need an x. If you were to add those, you would get 1x. These are equivalent steps that we took. So from here then, now we have 4 terms and our grouping works the exact same. You find your GCF, you divide it out, 1x in this case. Figure out what you're left with. That would be 2x minus 3. Same thing for the second set. Divide it by your GCF. See what you're left with then at that point. The parentheses should match. Whatever was multiplying with them moves into the second set of parentheses, and now you've factored this quadratic. That is our quadratic. That is our our factoring process for trinomials as well as four-term polynomials. If there's 4 terms, you can group it right away. If there's 3 terms with an a value, you do need to split the middle and continue the process. The reason we're looking at this factoring, though, is we want to be able to solve. So we go through our same steps. We still need to factor it. The reason we're factoring to solve is you need to create things multiplying to 0 in order for this process to work. Go through our division, divide out the GCFs, put it into our factored form where we have something like this. But notice on this one, we have these equations equal to 0. That means we're solving this. I need to find what x would be equal to make this equation 0. Well, the reason we do this is we're now showing 2 parentheses multiplying, and they multiply to a value of 0. Well, if you multiply 2 things to 0, what you know is at least one of those numbers had to be 0. So that tells me that the x plus 7 could be 0, or the x squared plus 3 could be 0. One of the parentheses would have to be 0 for that multiplication to give us a value of 0. So we solve to figure out what numbers would actually work. You subtract the 7 over, you get x equals negative 7 as one of your solutions. You subtract the 3 over and find that x squared equals negative 3. But you haven't solved yet. You need to take your square root on both sides. The opposite of squaring is square rooting. If you take a square root on both sides, you get plus or minus. We have the square root of 3 that does not simplify, but that 3 was negative. Remember, square roots of negatives always give us our imaginary values. This one, we would also get the letter I in our answer, and those are the other 2 answers. Positive I root 3 and negative I root 3. We get 3 solutions to this equation. If you're solving by factoring, you need to factor it first, then set your factors, your different parentheses, equal to 0 to finish the process. Thanks for watching. You could solve each of those other ones equal to 0 if you wanted to get that extra practice.